we have two wire. This is a wire 1, this is a wire 2, and both have the current passing through in the same direction. Let's call this I1 and let's call this I2 to differentiate it. Now we know this the current will produce the magnetic field, right? So let's consider the B1, which the magnetic field produced by the current one. So like this, and by using your right hand, you can determine the direction of this magnetic field. In this case, B1 is given in this direction, which the point that they contact with this wire 2, the magnetic field B1 is in this direction. Now, using your left hand, you can determine the direction of the force. You will get the direction of force is going to this direction. Let's call this F2, the force acting on the wire 2. And you do the same, you solve for the B2 and reach the magnetic field due to this I2, and you solve for the force on this wire 1. What you will get is the direction of this B will be going into this direction. This is a B2. This is B2, and the direction of the F1, the force acting on this wire 1 is given in this direction. So this is an attractive force. Now let's consider the force 2. The force 2 is actually due to the B1, so F2 B1, and the current is I2, and the length is the same for both wire. Now we know B1 will equals to mu naught I over 2 pi r. This r is a separation distance, and this I is I1 because the I1 produce this B1. We substitute this thing inside. F2 will equals to mu naught I1 over 2 pi r I2L. In this case, the current is the same uh, for both wires. So I1 equals to I2 equals to I. We can write this mu naught I square L over 2 pi r. Now we have all the information we need. Just for your information, the magnitude of this F1 and F2 is the same. You can try this the F1 B2 I1L, and you do the same for the B2 and you substitute inside, you will get the same equation as this. Now let's substitute the value and solve for this question. I 10 to the negative 7 2 5 over 2 pi r. R is the separation distance, so 4 by 0, 10 to the negative 2. So the F2 is given by 0.153 Newton, but actually this is also the magnitude for this the F1. The direction of the F2 is toward uh, the wire 1, and the direction of the F1 is toward the wire 2.